Okay, let's take a look at a couple of examples here from M.4. We're looking at dilations, enlargements, or reductions of a pre-image into another image. If we look at this, you can see that the pre-image is small. This is XTR, the triangle, and then the triangle X prime, T prime, R prime is an enlargement because it got larger. So we know that this is an enlargement. So what is the scale factor of the dilation? What is N? So what we want to do is we want to look at these lengths. And since the numbers are over here, the pre-image is only 4 units long, but the image is not 8, but it's both of these, 4 plus 8. The image is actually 12 units long. So what we can do is we can say, since the scale factor is bigger than 1, it's an enlargement, we'll put the 12 over the 4 and reduce that down to 3 over 1. So it's a scale of 3. So if we wanted to write the dilation rule, we could write D, and then in parentheses we'd write 3 comma X, because we're starting with X, and then we are enlarging what? XRT. Well, I should put a little triangle in there as well. That's the dilation rule for this. Okay, so let's take a look at another example. Let's actually do a dilation here. I had to actually rewrite this as I wrote it wrong originally. So what are the coordinates of the vertices after a dilation of 2 about O of triangle PZG? So we're going to take P, and we're going to basically make this length twice as long. It's pretty easy to do. We don't need a compass. All we need to do is kind of think of slope concept. So to go from 0, 0 to this point, we go over 1, 2, and down 1. We just do that again. Over 1, 2, and down 1. Put it right there. That's where you're going to find P prime. So P prime is going to be what ordered pair? It's going to be 4, negative 2. G is here. If we go down 1, 2, we go down 1, 2 more, it's going to be right there. That's G prime. So G prime is going to be 1, 2, 3, 4, negative 4, 0. And Z prime, which is over here, if we go left 2, up 1, we'll go left 2, up 1 again. It would be right there. Z prime would be at negative 4, positive 2. Okay, and we could draw the dilation, which is an enlargement, right here. And there is a picture of the enlargement around point O. Now, there's another way to do this. We didn't actually have to draw it. We could have just identified the points for PZG. Let's do it down here. P was 2, negative 1. Z was negative 2, 1. And G was 0, negative 2. And all we had to do was multiply each coordinate by whatever the scale was. And that would have been a 2. And that would have given us 4, negative 2, negative 4, positive 2, and 0, negative 4, which would have been the same points we would have gotten over here. So that's another way to do it in terms of just finding out what the actual ordered pairs are.